Now next is type of chemical reactions and their mechanism there. Suppose we have seen there the steps in the when a chemical reaction occur there. First of all, what happened? The older bond broken down and the new bonds had been formed there. And first of all, the older bonds between the elements had been broken down. Then the new bonds between the elements had been formed. In this case, first of all, what there first thing will be which one there, electron displacement in a covalent bond. In that case, there is a first effect will be which one there, inductive effect. Inductive effect is what there, it is a permanent effect, comes into existence when an electron withdrawing group, that is electron attracting or electron donating group, is attached to a chain or singly bonded carbon atom. So it results in a what there, it results in a displacement of a pi electron of carbon-carbon bond, leading to the development of partial positive or partial negative charges on the decreasing order of their magnitude of carbon atom in the chain there. It is refers to as I effect there. Now look at the here there. Suppose take an example of carbon atom attached to which one there, here the thing is given there, carbon is attached, carbon, then again carbon. When it is attached to an electron withdrawing group, suppose say an halogen there. Now what happened, due to this electron withdrawing group, it has the tendency to withdraw the electron toward itself there, so it develops a partial positive charge here and it is having a partial negative charge here. Now before this carbon atom, it is having a lesser partial positive charge. Here it is having the least partial positive charge over there. So the positive charges, the magnitude of positive charges decreases as we go along towards the end of the carbon atom, due to what there, an electron withdrawing group present at the end of the chain there. So this is called as which one there, it is called as plus I effect. It is called as minus I effect when carbon develops a positive charge over there. Similarly, when carbon develops which kind of charge, that is carbon develops a negative charge due to what there, see again here, carbon, then here one element attached to it, what suppose say Y, it is what their electron withdrawing group, so it will withdraw the electron towards this cell and there, so it develops a partial negative charge, it is having what their partial positive, then the partial negative charges decreases, then it is decreases more over there. So this one is the least positive charge, least negative, then lesser negative, then the more negative charge will be here over there. Okay, then this is having the positive charge over there. It is due to what their electron withdrawing group, electron repelling group there. This is an electron repelling group. So this occurs due to the electron repelling group, and this kind of effect will be called as the plus I effect. Before that we have seen that is which kind of effect, that is a minus I effect. In that case, an electron withdrawing group should be present over there. So this had been seen in which one the case there, it is shown mostly in the plus I effect will be shown by which one, the tertiary. The effect will be shown by the tertiary, then it is more in the tertiary, then in the secondary, then in the primary. So this follows this order there. And this is the plus or minus I effect that we have seen there. Next is about our inductive effect. Inductive effect, what does it tells about the effect there? The complete transfer of the shared pair of pi electron. Before that we have seen only the sigma electron. Here the complete transfer of shared pair of pi electron or multiple bond to one of the shared atom in the presence of an attacking reagent called the electromeric effect or the E effect there. So here there are two kinds of effect. See here, there is one effect can be shown by the plus E effect and another is the minus E effect. Plus E effect, when the electron or the pi bond transfer to that atom, just say when this attacking reagent attached to this carbon atom and the double bond shift towards that carbon atom, then that kind of effect will be called as the plus E effect. Okay, this is called as the plus E effect. when the electron of the double bond are transferred to that atom of the double bond which is to that atom of the double bond to which the attacking reagent is not attached, then that effect will be called as minus I effect. Here in this case the double bond between carbon and oxygen will be there. The double bond shift towards which one? There, oxygen, and the attacking reagent comes toward attaches to which one? There, carbon atom. So this kind of effect will be called as the minus E effect. So in that case they are having some differences there. That is one of the important thing that we are going to see there. It is shown by the containing single bond. It is shown by the having compound having the double or the triple bond. It takes place due to the presence of an electron withdrawing or electron repelling group over their saturated carbon chain. It is done by which one? Their attacking reagent attacks on the molecule containing the multiple bond. This is only the slight displacement of an alpha electron from one atom to the other there. This involves a complete transfer of the pi electron of the multiple bond to the other atom. So this is the electromeric and the inductive effect. Sorry, one more difference is also given there. The charges developed in an atom of the carbon chain are the small fractional charges which decreases rapidly as one moves away from the electron withdrawing or electron repelling group. The charges acquired against electron is the -1, while that acquired by the atom which loses an electron is having the +1 charge over there. It is done between only two atoms over there. Then next is the resonance. Suppose so many elements are having a different structures over there. Take an example, O3. O3 is ozone there. Ozone can be represented by this one there. Either the double bond will be between this one and this O will be like this one, or it can be this it can be single bond this oxygen and double bond to this oxygen there. Now here in this case we can have both the structures can be correct there. This structure is also correct, this structure is also correct, but due to what there, this is due to what there, the fluctuation of the pi electron there. So this creates both the structures can be regarded as correct structures, but which one is more correct? That these are called as the resonance structure there. See the definition. What is the definition of the resonance? It tells us about there the phenomena in which a molecule is represented by several electronic structure which do not differ in their much energy contained are obtained by the oscillation of pi electron. Here we have seen the oscillation of pi electron, that is double bond there. That is pi electron is called the resonance there. Such structures are called as the canonical form. Both the structures are called the canonical form, and the molecule is said to be resonance hybrid of this canonical form. Now along with this, these are the canonical form. What should be the resonance hybrid came about this one there? It should be single bond this oxygen, this single bond this oxygen. So it may be either here the double bond or it may be here. This is called the resonance hybrid of this canonical, both this canonical form. This is called as the resonance. Now resonance, what are the conditions for the resonance there? The relative position of all the atom of the carbon must be the same in the actual molecule there. The position should not be changed. All the resonating structure must contain the same number of unpaired electron. They should have what there? Same number of unpaired electron. The distribution of charges in canonical form within the framework, some common rules are given there. Like charges should not reside on the neighboring carbon atom there. Neighboring atom there. So the positive and negative charges should be away from the neighboring atom there. Unlike charges should reside opposite charges should be on closely situated atoms there. The positive charge should be as far as possible there, as far as on the less electronegative element there. So the energy content of all the contributing structures should be the same and nearly the same. Here what we can see here, it is having the plus charge, and this structure is having the negative charge. Here it is having the plus charge and it is having the negative charge. So what we are seeing there, the positive and negative are lying nearby atom there, and this same charges will be lying opposite to very far away from each other there. So this is all about what their resonance. Their resonance energy, the definition is also given there. The difference between the energy content of the resonance hybrid and resonance content of the canonical structure possessing least energy is termed as the resonance energy there. So this is all about our resonance there.